This is the Hazardous Weather Testbed 2023 training for Probsevere Lightningcast, created by the Probsevere team at the UW-Madison Cooperative Institute for Meteorological Satellite Studies, or CIMS. Members of that team include Mike Pavalonis, John Centineo, and Justin Sieglaff. I'm Scott Lindstrom from CIMS. There are different products within the Probsevere portfolio, and they all have a similarity. Given a collection of observations, what is the likelihood that something will happen in the next period of time, typically about 60 minutes? These products are all machine learning tools in one aspect. That is, they've used past observations and some kind of machine learning to create the probabilities. Probsevere versions 2 and 3 give the likelihood of tornadoes, hail, or severe winds in the next 60 minutes. Intense StormNet gives the likelihood of the most intense convection, and Lightningcast gives the likelihood of a GLM observation within the next 60 minutes. Lightningcast does something very similar to your human eye. Given a collection of ABI data, how likely is it that lightning will soon be occurring? Humans do this all the time with, for example, the day-cloud phase distinction RGB imagery. That's shown in an animation on the right. Are you anticipating the flash extent density observations that occur on top of this developing line of convection over Iowa because of the changes in the day-cloud phase distinction? Many people do that. The ability to predict a GLM flash probabilistically was initially requested by OPC and WPC for areas out over the ocean. The machine learning tool uses ABI observations and GLM observations and relates the ABI observations at one time to the likelihood of a GLM flash in the next hour. In the daytime, Lightningcast uses bands 2, 5, and 13, the same channels used in the day-cloud phase distinction RGB, and band 15. At nighttime, it uses just bands 13 and 15, that is the split window difference bands. The output is on a 2-kilometer grid remapped to a 10-kilometer grid that is roughly the same resolution as the GLM instrument. It's a quick algorithm and works with full disk, CONUS, and mesosectors from both goes east and goes west. You can probably list other reasons than are shown here why knowledge beforehand of when and where lightning activity will occur is useful. It's very useful for IDSS purposes. The 0 to 60 minute nowcast is the baseline capability. One could in principle create other probabilities, or refine this to use ground-based sensors, etc. This shows a clean example with variable lead time in the Midwest. The lead time is a function of how rapidly the storms develop. So you need to know the environment in which the storms are developing. That'll help you in your interpretation of the Lightningcast probabilities. For example, if convection is struggling to occur, you might not take action until the 50 or 75% contour shows up. If convection is more explosive, maybe seeing the 25% or 10% contour is all you need to take action. Know your environment. Although Lightningcast probabilities are frequently shown in animations, the time tendency of ABI information is not used in its creation. Note here how the Lightningcast does well despite some overlapping cloud cover. If your human eye can see lightning potential in the data, then Lightningcast should discern something as well. One thing you might note about Lightningcast: probabilities sometimes develop before anything substantial develops on radar. In other words, you can use this as a predictor of convective initiation, depending, of course, again, on the environment. Know your environment when using this tool. In this case, notice how the lightning cast probabilities extend northeastward into Michigan before you see anything happening on radar. And then slightly later, lightning is occurring. Here's an example for an outdoor event over Alabama. The insert shows a time series of lightning probabilities and also lightning events within that red circle where the IDSS event was occurring. Lightning cast ramps up and then lightning starts within the circled region of interest. Lightning cast also re-ramps up even as the lightning tails off. This is useful information because giving the all clear can be just as challenging as giving the first warning that lightning is imminent. So here at the end, notice how the lightning cast probabilities decrease as the horizontal extent of the lightning within the DSS circle tails off. This shows the critical success on the left for the probability of greater than 40%. So the CSI is greater in the regions that are more orange and yellow, and smaller for regions that are purple. What do you see in the CSI map? There are better statistics over land. There are better statistics closer to satellite nadir. Keep this in mind as you interpret the output. On the right-hand side, you'll notice better statistics during the summer than in the cool months. Why might the statistics be different over the ocean? Storm morphology is probably different. Still, this example shows high probabilities in regions of continuous lightning and regions of decreasing probability where lightning occurred. Note that not all 75% contours result in lightning. This is an example from HWT 2022. If you have thick cirrus, the lightning cast algorithm cannot see the visible and band 5 combinations that are related to the likelihood of imminent lightning. When a tower pops through the cirrus, suddenly lightning cast will notice and spike with a high value. You notice 5 minutes later, there are lightning observations. In the menu, you will notice something called PLAX. PLAX means parallax corrected. This might be a more useful field if you're keying on surface observations of lightning, for example, from Vaisala or Earth networks, and trying to compare it to GLM data. ABI data in AWIPS are not parallax corrected, so the comparison to the parallax corrected lightning cast probabilities might not match up as expected. Lightningcast is also available online with a Real Earth web mapping service. You can change the sector, so you can look at CONUS or mesosectors. And the website also includes both training information and information on how to acquire the data for GR Level X, so you can compare Lightningcast to radar. New in 2023 is you can get a meteorogram at various airport locations that show how Lightningcast there is changing with time, along with nearby observations of Earth network's total lightning. So if you toggle on meteograms, you'll see a bunch of red dots show up that are actually airports. Click on a location, and you'll see something where you can click a blue link for information at that airport, in this case Laredo. Here's what the meteorogram looks like. This will update automatically as new data becomes available. And you can change the location, you can change the time, and you can change what's being displayed. summary slide tells you some of the things you've just learned. Please use your time at HWT to give suggestions on how to best improve the use of this product, because it might become operational for you, currently planned in late 2024. So if you have ideas on how to improve it, let us know. Here's a list of websites for more information. Happy exploring. Finally, there are emails of various people to contact regarding this product. That's the end of this training. Thanks for listening.